All right. So um, I started playing music very young. I did math a little later. It wasn't until I got into music theory and things that I started seeing patterns. But there may not be lions or tigers or bears, but this will be a curious journey all the same. Sound, vibrations a second. It's measured in hertz. 1 hertz is 1 vibration a second. You have a low sound, it's low frequency. High sounds have high frequency. And so let's talk about how we hear sounds. Humans have a sound hearing range of about 20 hertz to 20 kilohertz. In car stereo terms, bass 20 to 200, mids are kind of your 200s to 4K. The reds and greens are 4K to 20K. If we think about a popular instrument, a piano has a frequency range that goes from about 27 hertz all the way up to 4K. And concert A440 is what you hear when orchestras are tuning up. There's other fun things that happen. Here's where the math gets pulled out. Take a given note and double its frequency, or multiply by 2 and divide it, and it becomes an octave. So, and so on. But there are some other octaves, and they happen quite frequently. You have basic things like, but then you have a whole bunch of other stuff. You have octaves down here, and this might sound familiar. Or if you're like me, from Nintendo. So octaves, that's what they sound like. It's math. It's 2x doubling in either direction or dividing by 2. So if we think a little more, scales in music are also patterns of ratios. The Greeks started with intonation, which is they took the break patterns and applied them ratios going either direction. But if you think about an octave of C and C, the perfect fifth is right in the middle. And chords are just organizations of those subsets of tones. So the 1, the 4, the 5. Notice the patterns between F and C, G and D, C and G. These are all 1.5x times the other. But then this leads us to curiosities around what we actually hear. We know that 2x sounds good. We know the 5 sounds good. But then there's other notes, like maybe that B and C up there. That doesn't sound so great, even when an octave below. But then why does it sound not so great? Why does a C to G sound so much better than a C to B? Do you notice anything about the numbers and the ratio to one another? Think back to our sound waves that we just saw. If we think about the frequency or the rate at which those sound waves might appear, and that is quite hard to see. But imagine a 1 and a 2x align twice as frequently every other iteration, whereas a 1 to 1.875 very rarely lines up, and that's why it sounds good or not so good to your ears. Both math and music have symbols. The top row probably look familiar to a bunch of you. The bottom row may look familiar to a bunch of you. Also, if you like math or music, that's probably why you're here. But with each of these symbols, there is also kind of rules around the way that we interpret them. There's an order of our operations in math, which says the order we do the things in. And in music, there's kind of like this decoder system to how you read the notes and the order you go through them in. And so this leads us to time signatures. Music has to move through time. And time signatures, those 4/4 numbers you see there, that's telling us how to read the notes and how to read the music. Top number is beats in a measure. Bottom number is what note gets the beat. That's 4/4. It's a very popular one. In 4/4 quarter notes, you have 2, 3, 4. We can have half notes of 1, 2, 3, 4. We can also apply math in other directions and come up with things like a whole note, which is 1, 2, 3, 4, or even eighth notes, 1 and 2 and 3 and 4 and. So we got a little bit of decoding there, how to read through a set of music and how the math relates them back and forth. But now comes the challenge. Let's put it all together. There's a time signature. We haven't gone over it yet. Remember when I said 4/4 is very popular? It is so popular, in fact, it's called common time. That means secretly 4/4. So when we think about our patterns of notes, what we have in the upcoming phrase is whole, half, half, quarter, eighth, quarter, quarter. And there you have it, a curious journey somewhere over the rainbow.
Yay. Thank you, Brian.
Woo!
Woo.
That was great.
That was awesome. That was so awesome.
Lots of
I
fun.
did like music theory an entire semester in about 5 minutes. You all can just pass the music theory exam right now.
Taking Theory 1 right now, and I cannot appreciate you more.
Oh, excellent. There you go. Stay tuned for Chris's talk. I haven't seen Eric's yet. Stay for that, but Chris especially. Because I got a sneak peek. And it's going to feed in very well.
All right. So how about anyone have any questions for Brian? Thank you, Brian. Renata.
Oh, people. Okay. Go ahead, Renata.
What are you the Q&A person?
I am the, yeah.
Okay,
But
I'm
I
gonna.
fell down on the job. I'm glad
Before
Anna
I
stopped
hand the baton to you.
it. Thanks. Renata.
Can you talk a little bit about the circle of fifths?
Sure. Circle of fifths is, so we think about that chart of like C to G, that's a fifth. And the circle of fifths is actually iterating through that fifth in all the directions. So starting with G, we go a fifth down to C, we go a fifth down to F, a fifth down to B flats, and then so on. And the reason if you keep going, it's called a circle is because it does complete eventually once you go through all the chords.
And what is the significance of that? Like, why do people always talk about the circle of fifths?
Ooh, I don't know. Can you tell us?
No, I wasn't playing.
I mean, I know in music theory, and Chris, you might be able to help here too with the barbershop stuff, but like the fifth is kind of like the natural dominant chord that leads back to one or back to the first one. So fifth, it just kind of sounds like it's the end of something, right? Like it's like 5, 1, and done, right? So the 5 leads to the 1, and if the 1 is someone else's fifth, it continues going in the other direction.
People always talk about it though, because music nerds are relentless and just love to share everything they know about music.
I'm seeing
Thank
Jane
you.
as well. Jane, you want to weigh in?
Sure. I mean, when I took 18th century counterpoint in college, the circle of fifths also is like, where, like if you look at Bach fugues and things, he goes through a pattern of modulations from key to key to key, and it typically will follow the circle of fifths. It's almost like energy orbitals in atoms, sort of like you can move in either direction depending on what you're trying to do harmonically.
Awesome. Thanks, Jane.
Jane, did you have a question too? I see your hand in the.
I did, yeah. So I know that from that same 18th century counterpoint class, I know that they used to consider the fourth to be a dissonance. And I'm wondering if you know anything about like why the fourth used to be a dissonance and then why they changed to now thinking it. Because right now I think it's like the seventh is really the only, or the second are the two that are more the dissonant notes, and the fourth we consider consonant now.
I don't know. If I think about the scale and where the fourth is the seventh of the fifth. And I know that's a lot of numbers to throw out, but like if we have just the fifth in this C, so G, when they add that fourth, it creates that dissonance between the two because it's the seventh iteral between the G and the F. It kind of wants to lean and resolve up to that fifth. So maybe it has to do with that. When you compare with just the root, I think it's quite normal because it's like even the wedding song, right? So that's not so dissonant. But then you got it to the fifth and you get the seventh in the other direction.
Any other questions? Renata.
I have a question.
Sorry. Okay, yeah, you can, someone else.
No,
can.
sorry, go ahead, Renata.
No, I've already asked one. I could ask like 1,000 though about this. Go ahead, Alina.
Okay. Sorry, I just had to get something from like some food delivered. So please forgive me if this was already asked, but when you said that the C and the C above it sound good because the waves coincide more frequently, why
Yep.
does it sound good when the waves coincide to us?
Oh, I think I'm gonna pause because I see Chaz raising hand, but I'm gonna say we should go through the rest of the presentations and see if we still have that question.
Fair enough. Okay.
That's a great question though.
Renata.
Thank you. So this is a question that it's very tangentially related to what you were talking about, but you said something about 4/4 being called common time.
Yes.
And my sister, who will be here soon, is doing a lot of stuff with like colonialism in music theory. And I'm curious if that has come up in any of the stuff that you've worked on, and if you like the idea of calling it 4/4 common time is like totally a Western thing. And I'm just curious if that's anything that you've ever come across or anything.
The only thing I remember is that even when like I was being taught it many years ago, I think common time can also mean 2/4. So I think it's a little of both. And Jane, you studied stuff in college too, so you might be able to help with this. But I think it can mean 2/4 or 4/4. And you have to look at the rest of the piece of the music to figure out which one it is.
Okay.
Common time, I've always only seen as 4/4. There is something called with a C and a little like bar, vertical bar
line.
through it that I
Cut time.
think is called cut time.
Yeah,
mean,
that
But
sounds
that's, I
familiar.
think,
But
that's like
to your question, Renata,
4/2 or something.
what we call music theory is the formalization of the common practice of white European men of a particular point in history. So the answer is yes. I mean, it's all that's what it is. I mean, we think of it as somehow kind of this like math, like in the premise, like we think of it as being independent of culture, but it's not. It's totally tied to the culture of that particular place in that particular time.
Thank you.
Ocean.
Yes, glad to be back here. Just to speak really briefly to the point Kenji just made, like people probably know this, but like African, music has oftentimes very different, tonal scales and things that sound terrible to our ears sound great to theirs. So like I'm curious about the mathematical relationships going on there. But my actual question is, this is really cool stuff. I love that you can see these relationships and everything. I'm curious, I'm guessing the answer is yes, but has it affected either your playing or your composition or both, like how you approach it?
Yes, because I think part of it is that when I play with other people, I'm forced out of my own like precognitions of where I might take a piece or hear something going. But the patterns become methods in the muscles of your fingers, and you're used to hearing things. And you can but if you know music theory, you're taught the patterns of like what chords often go to other chords and even related keys and key signatures. And you can't help but know those possibilities as you're playing through things. So I don't know if it's the frequencies as much that played into it, but probably the music theory that played into coloring how one thinks about music.
Sabrina.
Hey, are there any like times that you would want to purposely do the dissonance thing?
Yeah. You've probably, the times you've probably encountered it are, in classical music, it spans a lot of things. But if you think about if you were writing a soundtrack for your life or a film or something, you might think of like a scary or tense moment that you're putting in that film. And so the dissonance would help kind of add that tension and that unresolved sense to that underlying the theme. And then the resolution, if you got to it, would then offer some relief of the tension that you created.
Cool.
I'm going to ask one now. So we mentioned a little bit about like how different cultures have different scales or maybe notes. Do they actually write the music differently, or can you write all music in the Western style, or are there things that don't work?
I think there's things that, so what I remember of it is that we went through very quickly, and so only like a Western's very basic scale of just the key of C, and it was a major scale. If we made that scale minor, we would have played an E flat as opposed to an E, and it would be a slightly different ratio of the frequency of the pitch to the root note. But also there's at least 10 plus scales from Mixolydian to others, and some sound more foreign to us of Western nature than to Eastern. But I think that the ratio between the pitches, though, is going to be capable of being defined mathematically. It's just that the ratios are going to change because the scales are going to be different. The pitches used and the variance between them will change as the ethnicity or the origin of the music changes.
Cool.